I am Brian Robinson with the Advanced Reactors Technology Office. I'll be giving a presentation today over Advanced Technologies Development and Demonstration, also known as RC2. Quickly, I'm going to go over a few slides to kind of lay the foundation for our program. Our mission is to research and develop advanced technologies for significantly improve the efficiency, safety, and performance of advanced reactor systems. I'm going to go over this again in this presentation and show how it ties into the nuclear energy roadmap, and I'll address questions that arise from establishing or arose from establishing our Advanced Reactor Technologies program. As many of you have probably seen, this is our Advanced Reactor Technology Roadmap. For our program, it ties into two specific areas: to develop the improvement in affordability of new reactors and to develop sustainable nuclear fuel cycles. In establishing this program, we had several high-level questions that we needed to address, and I've provided them here on this slide. Quickly, we've looked at how to improve affordability of nuclear reactors, how to improve the inherent safety of advanced nuclear reactor systems, and how we can improve proliferation resistance. We also addressed nuclear waste for the advanced fuel cycle options and how to expand nuclear technologies into non-traditional nuclear energy markets. Lastly, we looked at how to increase performance and efficiency of advanced nuclear reactor plants through new materials, advanced systems, or components. Our work scope description for our NEIP proposal is provided on the slide. We wanted to adequately address advanced reactor development and eventual deployment, and we had to address a few questions, and we came up with these areas for this proposal. Basically, we're looking for improved design approaches to reduce cost and improvement in component performance. Additionally, we want to look at in-service inspection technologies for innovative reliability and maintenance applications. Also, compact heat exchangers for innovative steam generator systems. We want to evaluate and model the benefits of nuclear hybrid energy systems for process efficiency, renewable energy integration, and economic performance and life cycle greenhouse gas emissions. The big component with this is we've put these four areas out there specifically to address, and we want to emphasize experimental demonstration and validation. However, we're not looking for new concepts in the area of RC2. Example of our previous NEIP awards. This can also be found on the NEIP website. I have provided them. The ones that were awarded this year, I've just put a sample of them on this slide. Novel high temperature and radiation resistant infrared glass and optical fibers for sensing and advanced SMRs. Advanced high temperature inspection capabilities for SMRs. We find some of these valuable in moving towards the small designs that were needed and some of the limited and confined space entries that we have. We need to come up with different types of inspection techniques. Compact heat exchanger designs and testing for advanced nuclear reactors and advanced power cycles. We've also found these to be very important in their development and how to assist in not only small modular reactors but also advanced reactors as we go forward. We're also looking for creep, fatigue, and crack growth interactions for high temperature reactors. And lastly, as an example, we're looking for INC for fault-tolerant supervisory controls of SMRs. Again, these were last year's awards, but they give an indication of some of the areas that we're focusing on. That was a very quick presentation. Our NEIP proposal for RC2 has been severely reduced from last year. Last year was a broader example. Right now we're looking at components designs. And at this time, if there are any questions, I certainly would field those. All right, we have a question from the audience.
What kind of component design are you looking at, and what kind of reactor systems?
We're looking for both. We're looking for advanced reactor systems. The second part of that question will be first, but they could also be to support small modular or full-size reactors. Going back to slide 5, the components that we're looking for, I gave an example on slide 5 here. We're looking for compact configuration, but things that ultimately help us reduce costs and improve our component performance or efficiencies. Also, in-service inspection techniques. This could be as simple as robotics. It could also be some sort of infrared scanning capabilities. So that is just an example of it. Also for maintenance applications. Compact heat exchanger or innovative steam generator designs. I know there are a few items out there for helical coil types of heat exchangers. That would be another example of a component. And modeling benefits. One of the items that we've been focusing on is the hybrid energy systems and how they integrate into a series of power, not just for nuclear, but there are concepts out there that can put in different types of fossil energies linked into nuclear systems, greenhouse air or wind systems, and have other components that generate synthetic fuels. Those are all just examples of one series of a hybrid energy system. But that would be a good example of one from each one of those 4.
Are you looking for some work on new generation heat exchanger materials?
I am looking for work on materials for heat exchangers. We always have to be wary when we get those types of questions and expansions on the materials, as they still have to qualify through our ASME codes, especially for nuclear systems. So while we are looking for them, having those to be chosen that are outside of our spectrum, there will be more improvements on what our current certified materials are.
Is a component such as a pump for a high temperature molten salt reactor an emphasis area?
Yes. That would be an acceptable component that someone could submit.
The last question is, who were the winners of last year's awards? And I'm going to point them towards the NUP.gov website. That information is still available on the front page.
Right. And I also tried to provide those in the last slide, just a handout of it, but the link to the portal is at the very bottom of that slide 6 for me. It's easy to access it. If you go to that website, you'll see all of the list of the awards. All right.